Morning everyone. Now question number 66. Without performing actual long division, how can you tell if a rational number p by q will have a terminating decimal expansion? Without performing actual long division, how can you tell if a rational number p by q will have terminating decimal expansion? Right. Now answer is a rational number p by q in its lowest terms means that is in the form of simplest form. That means the both numerator and denominator having no common factors other than 1 will have a terminating decimal expansion if and only if the prime factorization of denominator q contains only the prime factors of 2 or only the prime factors of 5 or only the prime factors of both 2 and 5. That means the prime factorization of the denominator is in the form of 2 to the power of m into 5 to the power of n, where m comma n are the non-negative integers. Here we have two conditions. First one is the fraction should be is in the form of simplest form. First one, simplest. Second one, the prime factorization of the denominator is in the form of 2 to the power of m into 5 to the power of n, where m comma n are the non-negative integers or positive integers. When the given fraction can satisfy these two conditions, then that fraction is a terminating decimal. Denominator should be is in the form of 2 to the power of m into 5 to the power of n. Okay, that fraction is a terminating decimal expansion. For example, three by 20. In 3 by 20, numerator 3, denominator 20. Both numerator and denominator are having no common factors other than 1. Therefore, this is in the form of simplest form or simplified form. Now, denominator 20 can be written as 2 into 2 into 5. So, that is equal to 2 to the power of 2 into 5 to the power of 1. This is in the form of 2 to the power of m into 5 to the power of n. Both m comma n are the positive integers. Therefore, 3 by 20 is a terminating decimal. Next, 1 by 8. 1 by 8 is a fraction that is in form of simplified form, because 1 comma 8 having no common factors other than 1. Now, denominator 8 can be written as 2 to the power of 3. Also, this is in the form of 2 to the power of m and into 5 to the power of n, because 2 to the power of 3 can be written as 2 to the power of 3 into 5 power 0. Okay, so in 1 by 8, denominator is in the form of 2 to the power of m into 5 to the power of n, where m is equal to 3, n is equal to 0. both m comma n are the non-negative integers. Therefore 1 by 2 is a terminating, 1 by 8 is a terminating decimal expansion. Right. Next one. '67. Why do prime factors other than 2 or 5 in the simplified denominator cause a non-terminating repeating decimal? The base of our decimal system is base. Already we have basically the base of our decimal system is 10 or exponents of 10. Whose prime factors are 2 and 5? Any fraction whose denominator cannot be multiplied to become a power of 10 because it contains prime factors like 3, 7, 11 cannot be expressed as a primate decimal and must repeat. Here we have any fraction if it is in the form of simplified fraction. Simplified form, fraction is in the form of 2 to the power of m into 5 to the power of n. Then that fraction can be expressed as a powers of 10. Once again, if the denominator of a simplified fraction, if the denominator of a simplified fraction is in the form of 2 to the power of m into 5 to the power of n, if the denominator of a simplified fraction is in the form of 2 to the power of n into 5 to the power of n, then that denominator can be expressed as a powers of 10 power something, powers of 10. So in this case, this type of fraction is a terminating decimal. Okay, this one is clear. Now second condition, if the denominator of simplified fraction is not in the form of 2 to the power of m into 5 to the power of n, then that fraction cannot be expressed 10 power something, cannot be expressed 10 power something. Therefore this type of fraction is a non-terminating recurring decimal. For example, 3 by 20. 3 by 20. This is in the simplified form because 3, 20 having no common factors other than 1. Here denominator 20 can be written as 20 is equal to 2 to the power of 2 into 5 to the power of 1. So 3 by 20 equal to 3 by 2 to the power of 2 into 5 to the power of 1. Now we can multiply with 5 to the both numerator and denominator. That gives 3 into 5 by 2 square into 5 power 1 into 5. That is equals to 3 5s are 15 by 2 square into 5 square. That means 2 5 is 10, 10 power 2. Okay. When the denominator can be expressed as a prime factors of expressed as the 2 to the power of m into 5 to the power of n, then that denominator can be expressed as the powers of 10. Powers of 10. In this case, this is a terminating decimal. Now, one more example. Suppose 7 by 15. 7 by 15. 7 by 15 is in the form of simplified form because 7 comma 15 having no common factors other than 1. Here 15 can be written as 3 into 5. Here 3 is presented other than 2 and 5. 3 is presented other than 2 and 5. In this case, 15 cannot be expressed as a powers of 10. Only the prime factoration of the denominator is in the form of 2 to the power of m into 5 to the power of n. This fraction's denominator can be expressed in the form of 2 to the power of m into 5 to the power of n. So here in 7 by 15, 15 can be written as 3 into 5. Here 3 is presented, that is a other than 2 and 5. Here, so here 15 cannot be expressed in the form of powers of 10. Therefore, when the prime factors of denominator